This video is provided as supplementary material for courses taught at Howard Community College. And in this video, I want to talk about the average rate of change. So let's start out with the general concept of average rate of change, and then we'll go on to calculating it for a couple of different problems. So here's what average rate of change is about. Let's say I've got a graph, and I'm graphing on the x-axis time in hours, and on the y-axis I'm graphing distance in miles. And so I might have this graph and show what happens when a car moves at a constant rate. Let's say it's always going 50 miles an hour. So after 10 hours, that car has gone 500 miles. Okay, its rate of change is constant, so it's always going that 50 miles an hour. Now let's say there's a second car. The second car starts off at exactly the same time as the first car. It goes kind of slowly, and then it speeds up, then it goes slowly again, but after 10 hours, it's gone 500 miles. So if you think about it, its average speed is also 50 miles an hour. It covered exactly the same distance in exactly the same time as the car that was going a constant 50 miles an hour. So on average, it was also going 50 miles an hour. Therefore, its average rate of change was 50 miles an hour. And we could see that by thinking of the straight line that connects the point where the car began and the point where the car ended, and we see that it's 50 miles an hour. Its rate of change is 50. Okay, so that's what average rate of change is about. Now let's look at some problems. So sometimes you're going to be asked to calculate the average rate of change when you're given a graph. So here I've got a graph and I've marked 2 points on it. One point is -2, -1. The other point is 3, 5. We want to find the average rate of change from the first point to the second point. Okay, so what I'm going to do is I'm going to think of this graph as if there's just a straight line connecting those 2 points. And then what I would want to do is find the slope of that line. The slope is the same as the average rate of change. Well, we have a formula for slope. That's m for slope equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We can take these 2 points. I'll take the first point and think of that as x sub 1 and y sub 1. And I'll think of the second point as x sub 2, y sub 2. And now I'll just plug the values in for the x's and the y's. Okay, so y sub 2 is 5. And I'm subtracting y sub 1, which is -1. And then x sub 2 is 3. And I'm subtracting x sub 1, which is -2. So let's see, 5 minus -1 is the same as 5 plus 1. So that's 6. And 3 minus -2 is the same as 3 plus 2. So that's 5. So the average rate of change is 6/5, 6 over 5. Okay? Now let's see what happens if you're not given a graph. Maybe you're just given a couple of points and an equation or a function. So here we've got a problem that says find the average rate of change from x equals 2 to x equals 5 for f of x equals 3x squared minus 4x plus 7. Okay, so we've got 2 x's. We've got an x sub 1 and x sub 2. Let's start filling some information in. So for x sub 1, we can think of that as the 2. We want to find out what y sub 1 is. And for x sub 2, that'll be the 5. And we want to find out what y sub 2 is. Well, you remember when you have a function like f of x equals something, we can just think of that f of x as a y. So if x is 2, then I'll find out what y is by substituting a 2 everywhere where there's an x. So I've got 3 times 2 squared instead of x squared minus 4 times 2 plus 7. And let's see, 2 squared is 4. 3 times 4 is 12. Minus 4 times 2 is 8. Plus 7. So 12 minus 8 is 4 plus 7 equals 11. So that means this first point is going to be 2 comma 11. For the second point, when x sub 2 is 5, let's see, I'll have 3 times 5 squared minus 4 times 5 plus 7. 5 squared is 25. 3 times 25 is 75. Minus 4 times 5 is 20. Plus 7. And that's going to equal 75 minus 20 is 55. Plus 7 more is 62. So this is 62. And now I'll just find the slope. So I've got m equals y sub 2, 62, minus y sub 1, which is 11, and then x sub 2 is 5, minus x sub 1, which is 2. So 62 minus 11 is 51, and 5 minus 2 is 3, and 51 divided by 3 is just 17. So the average rate of change for this problem is 17. Okay? You might be given this one more way. You might be given a table of values. This is probably the simplest way of all. Let's say we've got this table of values for x and for y. Or instead of saying y, it might say f of x. It would be the same thing. And we want to know what the rate of change is, the average rate of change from x equals 4 to x equals 8. Well, we've got our x sub 1 and y sub 1 and x sub 2 and y sub 2. We have 4 and 6 and 8 and 30. So let's see, y sub 2, let's do m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That's going to be 30 minus 6 over 8 minus 4. 30 minus 6 is 24. 8 minus 4 is 4. 24 divided by 4 equals 6. So the average rate of change would just be 6. Now just one more note. Sometimes you're going to see, instead of this formula, which you're probably used to as being the formula for slope, you'll see the formula for average rate of change looking more complicated. It'll be f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. But if you remember that f of x is the same as y, then all we're saying is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay? And that's basically it. Average rate of change is as simple as figuring out the slope of a line. It's just sometimes the terminology gets confusing for people. Okay? So I hope this helped. Take care. I'll see you next time.